link to go change it, well, they got my email, so game over. Om nom nom, I had your data and I eated it. Okay, you guys are still awake. Super. Om nom nom. I'm sorry? ICANN has credit cards. Okay, thanks, bye. Super! Just wait till we get to one of the ending slides where I compare database security to an orgy. But, you know, you have to wait till the end for that one. Database security in general, information gained in one part can damage another, right? If I get a login to Facebook, I might be able to actually get somebody's information that they store in a Facebook app, which might include credit card information. Even though it's a different user or something, I've gained access to the database, and then from that I can find out more things. And there's a lot of access points. But, you know, I've already talked about it. The database management system itself controls the permissions, who can log in and where they're from. The operating system, the network, the applications control access, like physical access not physical access, but you know, actual, can I ping this database? Can I get to this database? And the applications control the interfaces. And the hand that rocks the cradle rules the world. So application vulnerabilities, you know, any data the interface can access might be compromised. This is not a lecture on how to make your code more secure. However, there's so many ways your code could be not secure. And again, because developers are really great with procedural languages or object-oriented languages, and SQL is a declarative language, which means you declare what you want, you don't declare how you do it. You don't say, okay, so go through this for loop and for each one do this, that, and the other. Thanks. Are you? Yes, more balls! Do you have a question?
No, I'm in here for a talk on why databases are hard to secure, and all we've heard is Facebook and email. And I guess my question is, are we going to talk about databases, or are we just going to be very general through this whole talk?
Well, you probably missed the first part where I said I'm really sorry that the description said we're going to be really technical and we're not.
No, I caught that.
Okay, super.
I guess we're just kind of getting some real general stuff in here, and you know, are we going to talk about databases at any time?
I'm glad you asked. Because how can we secure these? Otherwise, I have to stand up here a long time where you throw shmoo balls at me. Seriously, this was my next slide. I totally did not make this up. I'm like, well, I know it's later. Let me skip ahead a couple slides.
Seriously went and just bought 2 shmoo balls.
Seriously, damn, I'm good. That's all I have to say is I anticipated you guys hating me, right? Okay, auditing and monitoring. Prevention is one part of security. Another part is auditing so that you can fire someone later when they steal your credit card stuff. And you want to monitor because you want to know when somebody's in the middle of stealing your database security stuff. There are a bunch of companies that are doing this for lots of different database systems, so I'm not being general here. But you know, RippleTech.com has something for MySQL and Oracle. Guardium.com, which I mentioned earlier, has Sybase SQL Server, Oracle, MySQL, and these are things where you buy like a $50,000 appliance. You put it on, in front of the things or on your network, and it might act as a proxy, it might not, and it makes these audit trails and stuff. Now again, a lot of people will say, okay, well let me just make history tables for everything. Well, you can do that, but that's a lot of overhead, right? So you want to deal with the CIA principles, right? You want it to be confidential, you want it to be independent, and then I forget what the A is, but I always forget what the A is. So, if anyone knows. Accessible, yes, because we want the data to be accessible. Yeah, usually that's not a problem. Usually the data is a little too accessible. But you want it to be independent, right? You don't want your database auditing to get in the way of the database. And most, like SQL Server, you can turn on auditing, and Oracle, you can turn on auditing. But that doesn't really help because, first of all, the DBA can go and delete rows from the audit tables. It's not independent. It's on the same system. So not only is it bad because it's going to ruin the performance of your application, but it's bad because it doesn't even, who watches the watchers, right? If you trust me, great, but guess what? It's the DBAs that run off with the credit card numbers. So hard to do. You can audit with triggers so that you're not auditing every single change or view to every single object. That is one thing that you can do, and that is important. But again, you have to think and plan. This might be stuff you already know, and if you want to leave, that's great. But you know, thinking is so not done in so many ways, and it's really hard. And you could tell just by my facial expressions that I have 20,000 rants on that. So access points to the database. Who can log in? Well, you have the network, seeing traffic. That is, on the MySQL Forge, that's actually a code snippet. It's like a TCP dump code snippet, so that you can sit on the network and sniff the traffic and get all of the queries that are going back and forth, including things like set password equal to password, open paren, quote, whatever your password is, right? And again, there's not only a bash history or whatever, you know, shell history, there's also a MySQL history file. So for MySQL, that's something that if you set a password, well, great. If someone can go and look at your history and see what you set the password to, that's great. You know, you're compromised. There goes your data. So the access points on the data, you've got the data files themselves. You know, strings is a wonderful thing. You've got the log files. You've got the backups. If you're doing something like replication, whether it's Oracle, whether it's, you know, MySQL replication, it has to get the information from one place to another. And it might be being done by data blocks, you know, transferring data blocks over. It might be being done, you know, manually by rsync, which is kind of the same thing. And it might be being done by statements in a log, and the statements get moved. Again, somebody can intercept that stuff. They now can get your entire schema. They can find the user table. Maybe it's not users. Let me just check my notes here so that I can have things. All right. I think I'm actually at the point where oh, yeah, who can log in? I'm actually going to show some examples after this slide. Who can log in to the database? From where? What can they do? What consequences can they bring about? If anyone can read all of the tables in a certain database, then maybe you shouldn't put the sensitive information in something that anyone can read. Again, you know, data, you have access control. You can have, now here's the thing. Here's the stuff that you might know, you might not know. You can have access control level in every single major database management system. You have access control on objects like databases themselves, the tables in the database, the columns in the tables. So you can say, okay, Sheeri can look at everything except for this one column in this one database, and also store procedures, who can execute them, who cannot. You can use views, which is also another way to say, okay, Sheeri can't access this table with important data, but she can access this view, and the view is everything in that table but the important data. And in order to do that, you have to figure out, well, what's sensitive, what's important. You know, do you need to encrypt your backups? How important is it? Are you backing up your code that has your algorithms in them for encrypting the data with, you know, are you backing them up in the same place? Okay, so here's some code. I'm not necessarily going to go through and explain it all, but it's probably pretty, you know, obvious what it is. You know, there's default table spaces. If your default table space is the system table space, then you can do some damage, right? You could stuff it full of data so that there's no room left. It's like stuffing your var partition full, right? Nothing will work. Temporary table space, same thing. If you have a temporary table space, you know, if I have a temporary table space and the web app has a temporary table space, and I fill it up and the web app can't do anything now because now it can't make a temporary table when it tries to do a huge join, great, I've just denial of service the, you know, the database because, you know, whether it was on purpose or not. Quota, that's another thing that you could say, okay, well, I don't want them to have an unlimited quota. I'll give them a quota. Profile is a role that they have, so you can give them the sysdba profile or the sysadmin profile in SQL Server. And you can expire the password. You can lock or unlock the account. This is actually Oracle, actually, by the way. So in MySQL, you grant a privilege type, and there's huge amounts of privilege types, everything from select and update to things like replication and super. There's a super privilege. And you can do it on a table, a database name, like everything in a database, everything in a database or a table, on a routine, which is store procedure, to a user. That user string includes a host, and you can require it to have, and require will like require X509 requires it to have a particular certificate. If you say issuer, it has to have an issue by can I take back that part where I said I want your balls? No, it's all right. the issuer is you have to have a certificate by a particular